taking a look at a few application problems from 14.1. We have to recall the Pythagorean theorem for right triangles, that we have a squared plus b squared equals c squared. And in this problem, they give us the b and the c value, but the a value is unknown. So I just left I could have substituted a different variable, but I like to use the a here. So I put these values in, and we get to this point of the problem. And why this is in section 14.1 is because at this point, we have the square isolated. Now, normally we put the plus or minus here, but since we're talking about the length of a side, we're not going to have a negative value for the length of a side. And we get a is equal to the square root of 119. Now, we would simplify that if we could, but I don't believe we can break that apart and simplify it. So, and then this problem, they say that the hypotenuse or the diagonal of the square is 10, and then it says find the length of one of the sides. Well, we know these two sides are equal because it's a square, and so I just called them x, and so I have x squared plus x squared equals 10, forgot that, squared, which is 100. So now, again, this is why this is in 14.1. We're going to use the square root method. We're going to divide by 2 here. We get x squared is equal to 50. And then we have our squared isolated, so we can take the square root. And again, we're only going to deal with the positive square root because we're dealing with a geometric shape here. And we're going to get x is equal to the square root of 50. But you'd have to remember that the square root of 50 can break down into the square root of 25 times the square root of 2. And we want this in simplified form, so we'll have 5 square root of 2 for the length of one of the sides. And then this last one here, they say the hypotenuse of the triangle is twice, okay? There's the twice or double the length of one of the sides. So I let one of the sides be x, and then the hypotenuse is double that. And then the other side is radical 12. Well, again, the Pythagorean theorem here, and one thing students forget to do here is to square this 2 and make sure to get the 4 there. So at this point, I'm going to subtract x squared. That's going to isolate my squared term. So I have 12 is equal to 3x squared. Then I'm going to divide by 3 to get x all by itself, okay, or the x squared, and 4. And then I can just take the square root, or you might just be able to spot the answer at this point, but using what we learned in this section, and we get x is equal to 2. So a little bit of use of the Pythagorean theorem.